Good morning students. In this video today I'll discuss about mole concept and calculation of empirical and molecular formula. So first you have to know what is atomic mass. In simple word, atomic mass means mass of a single atom. In simple word, atomic mass means mass of a single atom. Okay, and atomic mass, that is mass of a single atom, is very small. That's why the mass of a single atom is determined with respect to different elements, such as with respect to hydrogen, with respect to carbon, with respect to oxygen. Okay, and scientifically atomic mass defined as mass of a atomic mass of an atom of an element is equal to mass of that element divided by 1/12 into mass of a carbon 12 atom. This scientifically scientifical definition of atomic mass. It is also called relative atomic mass. This is because the atomic mass of different elements are measured with respect to mass of some other elements such as carbon, hydrogen or oxygen. You have already studied in class 10th, that is you can calculate atomic mass in different scale. You can calculate relative atomic mass in different scale, such as in carbon scale, in hydrogen scale and in oxygen scale, and carbon scale is most applicable. Okay, and here one thing I want to mention you, that what you have to remember. You have to remember that atomic mass of different elements, like relative atomic mass of hydrogen is equal to 1. Okay, one more thing, that is atomic mass is expressed in AMU unit. AMU, that is atomic mass unit, and 1 AMU is equal to 1.66 into 1.66 into 10 to the minus 24 gram. 1 AMU is equal to 1.66 into 10 to the power minus 24 gram. You have to remember this one, 10 to the minus 24 gram. Okay, so you have to remember the atomic masses of different elements, such as atomic mass of hydrogen is 1 AMU, atomic mass of carbon is 12 AMU. Okay, atomic mass of oxygen is 16 AMU. So these atomic masses you have to remember. Atomic masses of sulfur is 32 AMU, atomic mass of sodium is 23 AMU. Okay, so atomic masses of different element you have to remember. This is important, otherwise you will not be able to calculate molecular mass of different element. Okay, and atomic mass is expressed in AMU unit, atomic mass unit, or it is also expressed in unified unit. Okay, that is today's AMU has been replaced by U, which is known as unified masses. Now see what is molecular mass. In simple word, like atomic mass, molecular mass means mass of a single molecule. Okay, and molecular mass is the sum of atomic masses of the element present in a molecule. For example, in water, 2 hydrogen and 1 oxygen atoms, 2 hydrogen atoms and 1 oxygen atom are present. So what is the molecular mass of water? You can calculate the molecular mass of water by adding the atomic mass of hydrogen and oxygen. You know atomic mass of hydrogen is 1, so 2 hydrogen, that means 2 into 1, plus atomic mass of oxygen is 16, so 2 into 1 plus 16, that is 18. So 18 AMU is the atomic mass of molecular mass, as water is a molecule, so 18 AMU is the molecular mass of water. Okay, so you can calculate molecular mass of different molecules by doing sum of atomic masses of the elements present in the molecule. Okay, and molecular mass is obtained by multiplying the atomic mass of each element by the number of its atom and adding them together. For example, molecular mass of methane, which contain 1 carbon atoms and 4 hydrogen atoms. So what is the molecular mass of methane? Methane means CH4. And remember that atomic mass of carbon is 12. So 12 AMU or 12 U. 12 it is actually 12.011 U. That means 12. Atomic mass of carbon is 12.00011 U, or you can also write 12 U plus 4 into atomic mass of 4 hydrogen, that is 4 into 1.00 U 008 U. You can also write it is as 1. Okay, so the molecular mass of methane is 16.043 U, or you can also write 16 U. 16 U means 16 atomic mass unit is the molecular mass of methane. So first you have to remember the atomic masses of different element, like atomic masses of hydrogen is 1 AMU, or it is actually 1.008 AMU, or you can also write 1 AMU. Atomic mass of carbon is actually 12.011 AMU or U. You can also write as 12 U. Okay, so first you have to remember the atomic mass of different elements. Okay, now here one problem is given: calculate atomic mass molecular mass of glucose. Molecular mass of glucose. So how to calculate molecular mass of glucose? In glucose 12 the formula is C6H12O6, and you know that for each carbon atom atomic mass is 12, so 6 into 12 plus 12 hydrogen, that means 12 into 1, 12 into 1 plus 16 to 16. This will be the total molecular mass of glucose molecule. Okay, now here it is given 180. The solution is also given. The molecular mass of glucose become 180.162 U, or you can also write 180. Now say formula mass. What is formula mass? Like molecular mass, for ionic compounds such as NaCl, KCl, calcium oxide, for ionic compounds, instead of molecular mass, the term formula mass is used. But both molecular mass and formula mass both are same in both are same. Okay, formula mass means molecular mass, but this term is valid for ionic compounds such as NaCl. This is because the single molecule of ionic compounds does not exist. Okay, so some substances such as sodium chloride do not contain discrete molecules, as their constituent units. In such compounds, positive charge particles, that is sodium Na plus, and negatively charged particles, that is Cl minus, in case of NaCl, are arranged in a three-dimensional structure. and their discrete molecule does not exist. That's why for ionic compound, instead of molecular formula, the instead of molecular mass, the term formula mass is used. Okay, and you can take it like this: molecular mass is also equal to the formula mass is also equal to the molecular mass for ionic compound. Okay, so that means formula mass of sodium chloride is equal to, sodium chloride means NaCl. In sodium chloride, one sodium atom, one Cl minus atom. So formula mass of sodium chloride will be equal to atomic mass of sodium plus atomic mass of chlorine. So atomic mass of sodium is 23 U and atomic mass of chlorine is 35.5. That is, formula mass of sodium chloride will be 58.5 U. Okay, so basically formula mass and molecular mass both are same, but the term formula mass is used only for ionic compounds. Now, what is the mole concept and molar masses? What is mole concept? Okay, mole, 1 dozen means 12 item, and 1 gross means 144 items. Similarly, 1 mole means 6.022 into 10 to the 23 items. Okay, this number indicates 1 mole. Okay, so 1 mole substance means 6.022 into 10 to the 23 particles. This number indicates 1 mole. Like 1 gross means 144. Similarly, 1 mole means 6.022 into 10 to the 23. Okay, so we can say 1 mole hydrogen atoms means 6.022 into 10 to the 23 hydrogen atoms. Similarly, 1 mole oxygen atom means 6.022 into 10 to the 23 oxygen atoms. Similarly, 1 mole carbon dioxide molecules means 6.022 into 10 to the 23 carbon dioxide molecule. Similarly, you can say 1 mole electrons means 6.022 into 10 to the power 23 electrons. Okay, so 1 mole is equal to this number 6.022 into 10 to the 23. Okay, and this number is known as Avogadro constant, and which is denoted by Na, capital N, small a. Okay, so Na is equal to Avogadro number. Na is Avogadro number, which is represented by Na, is equal to 6.022 into 10 to the power 23. Okay, and the amount of substance which contain 6.022 into 10 to the 23 particles is known as 1 mole substance. Okay, amount of substance which contain 6 Avogadro number particles. If the particles may be atom, the particles may be molecule or ions also. Avogadro's number or Avogadro's constant means 6.022 into 10 to the 23. Okay, so amount of substance which contain Avogadro's number particles is known as 1 mole substance. For example, 1 mole sodium chloride means 6.022 into 10 to the 23 formula unit of sodium chloride. Okay, and the mass of 1 mole of substance in gram is called molar mass. If the mass of 1 mole substance is expressed in gram, then it is known as molar mass of the substance. For example, molecular weight of water is 18 AMU. So molecular weight of water is 18 AMU. So molar mass of water is 18 gram per mole. If the molecular weight is expressed, okay, or if the molecular mass is expressed in gram, then it is known as molar mass. Okay. Similarly, molecular mass or molecular weight of sodium chloride is 58.5 AMU or U. So molar mass of sodium chloride is a 58.5 gram per mole. Okay, so molar mass of water is 18.8 or 18 gram per mole. That means 18 gram water contain Avogadro number particles. Similarly, molar mass of sodium chloride is 58.5 gram per mole. So 58.5 gram sodium chloride contain Avogadro number particles. Okay, so so 1 mole of substance always contain Avogadro number particles. Okay, and one more thing you have to remember, that for gaseous substance at HTP, volume of 1 mole of gas is 22.4 liter at HTP. Volume of 1 mole of gas for gaseous substance, the volume is 22.4 liter. Okay, or in milliliter it is 22,400 ml, means 1 mole gas at HTP, standard temperature and pressure. Okay, so 22.4 liter means 1 mole substance, 1 mole gas at HTP. That means mass of 22.4 liter of any gas is equal to molar mass of that gas. Okay, for example, 22 point at HTP 22.4 at HTP 22.4 liter CO2 is equal to molar mass of carbon dioxide, that is carbon is 12 plus 2 into 16, that is 44 gram. Okay, so 22.4 liter carbon dioxide means 44 gram carbon dioxide. Now see calculation of percentage composition. Percentage composition calculation. How to calculate percentage composition? Percentage composition of an element in a compound is equal to mass of that element in the compound into 100 divided by mass molar mass of the entire compound. Okay, using this formula you can calculate the mass percentage of different element present in a compound. So for example are given. Water, in water calculate the percentage of hydrogen and oxygen. So first you have to calculate molar mass of water, that is 18 gram per mole. Molar mass is 18 gram per mole. And now percentage of hydrogen, you can see in water 2 gram, in 18 gram water 2 gram hydrogen and 16 gram oxygen is present. In 18 gram water, molar mass of water is 18 gram per mole. So in 18 gram water 2 gram hydrogen and 16 gram oxygen is present. So percentage mass of hydrogen is 2 divided by mass of hydrogen present in water divided by molar mass of the compound, that is water, that is 18 into 100. So mass percentage of hydrogen in water is 2 divided by 18 into 100, that is 11%. Similarly, mass percentage of oxygen, in water 16 gram oxygen is present in 18 gram water. So mass percentage of oxygen is 16 divided by 18 into 100, that is 88.79. Okay, so one more example is given. Molecular percentage of carbon, hydrogen and oxygen in ethanol. Calculate percentage of carbon, hydrogen and oxygen in ethanol. The formula of ethanol is C2H5OH. C2H5OH. OH. So first you have to calculate total molecular mass of ethanol. So for molecular mass of ethanol is 2 into 12 plus 5 into 1 plus 6 is 2 into 12 plus 6 into 1 plus 1 oxygen, so plus 16. In ethanol, 2 carbon, 6 hydrogen and 1 oxygen. So total molar mass of ethanol is equal to 46.682 gram, 46.068 gram, that is 40, you can also write 46 gram. Now calculate the percentage of carbon. In ethanol, mass of carbon is 2 carbon atoms, so 2 into 12, that means 24. Mass of carbon is 24 divided by molecular mass of ethanol is 46, so 24 divided by 46 into 100, that is 52 percentage. Okay, mass of hydrogen is equal to mass of hydrogen, percentage of hydrogen is equal to mass of hydrogen, that is in ethanol, that is 6 gram divided by molar mass of compound is 46 gram into 100, that is 13.13% hydrogen, and mass percentage of oxygen is 16 divided by 46 into 100, that is 34.73%. Okay. Now see how to calculate empirical formula and molecular formula. This topic you have already studied in class 10. So first you have to know what is empirical formula and what is molecular formula. An empirical formula represents the simplest whole number ratio of various atoms present in a compound. An empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas molecular formula shows the exact number of different types of atom present in a molecule of a compound. For example, glucose, the formula of glucose, actual formula of glucose, actual molecular formula is of glucose is C6H12O6. So in glucose, the ratio of number of atoms present in glucose molecule, one molecule of glucose, is carbon is to oxygen, hydrogen is to oxygen ratio is 6 is to 12 is to 6, that means 1 is to 2 is to 1, 1 is to 2 is to 1. So in molecular formula of glucose is C6H12O6, but its empirical formula is CH2O. Okay, simplest whole number. So empirical formula represents the simplest whole number ratio of various atoms present in a compound. So molecular formula of glucose is C6H12O6, but its empirical formula is CH2O. Okay. So how to calculate empirical formula and molecular formula? Here I have taken an example. See this example, problem 1.2. Here one question is given: a compound contains 4.07% hydrogen and 24.27% carbon and 71.65% chlorine, and its molar mass is also given, that is molar mass of the compound is 98.96 gram. What are its empirical and molecular formula? So first you have to calculate what is empirical formula. Following step you have to follow. First you have to convert the percentage percentage to grams. So conversion of mass percent to gram, that is 4.07% hydrogen means out of 100 gram hydrogen is 4.07 gram. Carbon is 24.7%, 24.27%, that means the mass of carbon is 24.27 gram out of 100 gram, and chlorine is 71.67%. That is, mass of chlorine is 71.65 gram out of 100 gram of the compound. Okay, so first you have to convert mass percent to gram. Then second step, convert into number moles of each element. That is mass per gram to, that is mass to number of moles conversion. Okay, so in the compound hydrogen is present 4.07 gram. If you divide the mass of that element by its atomic mass, then you will get the mole number of that element. Okay, so hydrogen is present 4.07 gram, and you know atomic mass of hydrogen is 1.008 or 1. So the moles of hydrogen is 4.07 divided by 1.008, that is 4.04 moles. Moles of carbon, carbon is present 24.27 gram, and if you divide this mass of carbon, that is 24.27, if you divide by atomic mass of carbon, that is 12, then you will get the moles of carbon. Okay, so number of moles of carbon is 24.27 divided by 12.01, that is 2.021. And similarly, moles of chlorine will be equal to mass of chlorine divided by atomic mass of chlorine. Okay, so how to get the value of number of moles? So number of moles is equal to mass of that element divided by atomic mass of that element. Mass of given mass of that element divided by atomic mass of that element. Okay, so in the following compound, number of moles of hydrogen is 4.04, number of moles of carbon is 2.021, number of moles of chlorine is 2.021. Next step, divide the mole values, divide the mole number obtained by smallest number. So out of these three values, 3 moles, the smallest one is 2.021. So you have to divide all these three values by 2.021 to get a simplest ratio. Okay, so since 2.021 is the smallest value, division by it gives a ratio of 2:1:1 for hydrogen, carbon and chlorine. Okay, so in next step you have to divide this mole number by the smallest number to get the simplest ratio. Okay, so divide by 2.021. Okay, and after division you will get it will be equal to 2:1:1. So empirical formula of the compound will be equal to CH2Cl. Okay, so next step 4 is write empirical formula by mentioning the numbers after writing the symbol of respective elements. So in this case, the empirical formula of the compound is CH2Cl, 1 carbon, 2 hydrogen and 1 chlorine. Okay, now how to write molecular formula? Okay, so before writing molecular formula, you have to calculate empirical formula mass according to the empirical formula. Empirical formula of the compound is CH2Cl. So what will be the empirical formula mass? Empirical formula mass will be mass of 1 carbon, that is 12, plus mass of 2 hydrogen, that is 2 into 1, plus mass of 1 chlorine, that is 35.5. The mass of empirical formula mass of the compound is equal to 49.48 gram. This is the empirical formula mass, and molecular mass of the compound is also given 98.96 gram. So divide molar mass by empirical formula mass, you will get you will get this number n is equal to molar mass divided by empirical formula mass. Molar mass of the compound is 98.96 divided by empirical formula mass is 49.48. So it is close to 2. Okay, so now multiply empirical formula by n, by the value of n. Multiply empirical formula by n, obtain, okay, by dividing molar mass by its empirical formula mass. So molecular formula of the compound will be equal to C2H4Cl2. Empirical formula is CH2Cl and multiply by 2 because value of n is 2. So the molecular formula will be C2H4Cl2. Okay, so using this following step, you can calculate empirical formula and molecular formula of different compounds. Their mass percentage will be given, and using the value of mass percentage you can calculate the empirical formula of different compounds. You can calculate empirical formula of empirical and molecular formula of different compounds. Okay, in the next video I will discuss about different types of concentration, method of expression of concentration of a solution. Okay, that is molarity, normality, mass percentage, volume percentage. Thank you, students.